We have already learned what are kinematic equations and how to use kinematic equations to find out unknown quantity related to moving object, which shows uniform acceleration. So, the kinematic equations are V is equal to U plus AT, S is equal to UT plus half AT square, V square equal to U square plus 2AS. Today we will learn how to derive or how to write down proofs for these kinematic equations. What do you mean by to derive or to write down proof for any equation or for any formula? To derive a formula or equation means to deduce or to prove that formula from a set of already known or already established principles or facts. So, today we will prove kinematic equations. You might have written proofs earlier in geometry, but I guess this is your first time you are writing proof in science. So, first we will derive first kinematic equation. For that, we have to consider one example or one situation. So, let us see what that situation is. Let us consider an object moves from point A to point B. When object is at point A, it is moving with some velocity which is non-zero, that is u. And when object reaches at point B, it gains the velocity v. And this change in velocity takes place in time t. Let us express this situation in motion graph. Already you have studied motion graphs, right? So we will derive these kinematic equations with the help of motion graphs. Here in the situation, they are talking about change in velocity of moving object in time t. So here the graph of velocity against time is drawn. So what we were talking about, which situation we have considered? An object moves from point A to point B. When object is at point A, it is already in the state of motion. Already it is moving with some velocity, that is u. When object reaches point B, its velocity becomes v and the time required for the same is t. So to enclose that time period or to find out that time period, let us draw perpendicular from point B and A on x-axis. So let us draw perpendicular from B on x-axis. Let us label the point which meets where perpendicular from point B meets x-axis, that is C. Let us label the point at which perpendicular from A meets x-axis, that is D. So, what is the time in which this change in velocity has been taken place? That time duration is t. Now, for the sake of derivation or proof, we are going to do one construction. We are going to draw one perpendicular from point A to segment BC, and the point at which this perpendicular meets segment BC will be labeled as, say, E. This construction is done to make our things easier when we will start deriving the equations. So with this graph, let us derive first equation. Again here also I have drawn the same diagram that we have developed earlier. So what is first kinematic equation? V is equal to U plus AT. Now here we are going to find out value of V. We are supposed to find out something which is equal to V. So now look at the diagram and find out which segment corresponds to V. Yes, segment BC corresponds to V. Look at the diagram. So, segment BC corresponds to V and this segment BC is made up of what? Segment BC is equal to BE plus EC. So let us find out value of segment BC. So BC is what? For BC, what can I write down? V. And for BE, actually it is V minus U. BE shows change in velocity. But instead of writing V minus U directly, I have written BE as it is. Why is it so? You will understand in our further discussion. And this EC is what? EC corresponds to AD. AD corresponds to what? U. So EC is equal to U. Now, what is BE? What I have told you, BE is nothing but change in velocity. Change in velocity means final velocity minus initial velocity, and that is V minus U. So if I substitute V minus U for BE, let us see what happens. So V is equal to V minus U plus U, that will give you V is equal to V. But right now we are after deriving V is equal to U plus AT. So instead of substituting B is equal to V minus U, we are supposed to substitute something equivalent to V minus U. Otherwise, we will get V is equal to V, which is not required by us. Or this is not our destination. We are supposed to find out, or we are supposed to prove V is equal to U plus AT. So for BE, we cannot write down V minus U. Instead of that, we will find out something which is equivalent to V minus U. Now, the example which we have considered, that is the object moves from point A to B. It shows change in velocity in time t. That means it shows accelerated motion. How to find out acceleration of this object? What is the formula to find out acceleration? A is equal to V minus U upon t. So let us write down that. A is equal to change in velocity upon time, that is A is equal to V minus U upon t. And now see here, BE is equal to V minus U. If you look at the diagram, you will come to know this, right? So instead of V minus U, I can write down BE. And let us rearrange the terms. We will get BE is equal to AT. So we were finding something which is equivalent to V minus U. So here V minus U is equal to AT. So now let us come to our previous equation. Here V is equal to BE plus U. So instead of BE, I can put AT. And this is how I have proved first equation of motion, that is V is equal to U plus AT. Let us discuss second kinematic equation. So for that also we will refer the same diagram. So what is second kinematic equation? S is equal to ut plus half at square. Here S is equal to something. That means we will find out value of S. S means what? Displacement. You have studied motion graphs earlier, right? So when you studied motion graphs earlier, you must have studied how to find out displacement by using velocity time graph. So how to find out displacement here? The area under the curve of velocity time graph is nothing but displacement. Here there is no curve, here graph is straight line. Why? Because object shows uniform acceleration. So here area under the straight line, that is AB, is nothing but displacement. So area enclosed by quadrilateral ABCD is nothing but displacement. So this area enclosed by ABCD can be calculated by two ways. Now if you look at this quadrilateral, it is trapezium, right? What kind of quadrilateral it is? Trapezium. We can use direct the formula to find out area of trapezium, or we can divide this quadrilateral into two geometrical figures. One is, look at the diagram, you will understand then. One is right angle triangle BEA, and the second is AECD. rectangle. So if we find out area of this rectangle and right angle triangle and add them together, we will get the area of quadrilateral ABCD. We are after finding out area of quadrilateral ABCD to find out displacement shown by this moving object. So let us divide this entire big quadrilateral into two geometrical diagrams. So area enclosed by triangle BEA, BEA is right angle triangle, right? And area enclosed by rectangle AECD and add them together. Okay, so let us write down the formula to find out these areas. So what is it? Half base into height, because BEA triangle is right angle triangle and this AECD is rectangle. So formula to find out area is length into breadth. So let us substitute the values now. Half base here, BEA. Look at the triangle BEA. What is base? Base is AE, right? And what is height? BE. Here AECD, in this rectangle, what is length? AE you can write, or even you can write DC. In the same way, what is breadth? You can write either EC or you can write down AD. So we have substituted the values. Now we are supposed to substitute the values. So for AE, what can we write down? For AE, we can write down it is equivalent to DC, that means T. For BE, what can we write down? BE's value, do you remember? We have already calculated BE is equal to V minus U, or else what? What can we write down? BE is equal to 80, right? We have used it previously. Then what is AE? AE is equivalent to DC, that is equal to T. What is AD? AD is nothing but U. AD corresponds to U. Let us substitute these values and let us solve further. S is equal to then UT plus half AT square. That is what we were looking for. This is the proof for second kinematic equation. Now the third kinematic equation we will derive. For that we will refer the same diagram. What is third kinematic equation? V square equal to U square plus 2AS. Here also unknown quantity is S, means displacement. Let us find out value of displacement. Now here also in velocity time graph, how to find out value of displacement? Area under the curve, or here in this case straight line AB, right? So area under the curve AB, straight line AB, means area enclosed by quadrilateral ABCD. Now if we employ the same technique as before, that means dividing this quadrilateral into geometrical diagrams, that means right angle triangle and rectangle, and if add them together, we will get the same formula, same equation. We don't want that now, right? So what we will do is, we will use the second method. That means, what kind of triangle, quadrilateral it is? It is trapezium. How to find out the area enclosed by any trapezium? There is a formula for it. What that formula is? S is equal to half the addition of two parallel sides into height. We will use this formula to find out area enclosed by quadrilateral ABCD, since it is trapezium. So let us substitute the values. Half is equal to S is equal to half, which are two parallel sides here, BC plus AD. And what is height? Either you can write down AE or you can write down even DC. Let us put the values now. S is equal to half. BC means what? V. AD means what? U. And AE means what? AE corresponds to what? T. Now think, which kinematical equation we are after deriving? V square equal to U square plus 2AS. In this equation, Do you find t anywhere? No. So we don't want this t here. What can be done? Can we simply erase that? No. We are supposed to write down something which is equivalent to this t. So what to do now? Again, we will take the help of formula for acceleration. A is equal to v minus u upon t. Let us rearrange the terms and then we will get t is equal to v minus u upon a. Let us substitute this value for t here in this case. S is equal to half v plus u into v minus u upon a. Instead of t, what we have substituted? V minus u upon a. Let us rearrange the terms. S is equal to 1 upon 2a multiplied by v plus u, v minus u. Doesn't this sound familiar to you? Yes, you must have heard about algebraic identity a plus b, a minus b. Okay, so what can we write down here? Instead of v plus u and v minus u, we can write down v square minus u square, right? So let us write down that. S is equal to 1 upon 2a multiplied by v square minus u square. Let us merely rearrange the terms. Let us take 2a to the left hand side. So it becomes 2as is equal to v square minus u square. Let us further rearrange the terms to get the equation we were looking for. So v square is equal to u square plus 2as. So here we have derived all the three kinematic equations. Go through this video again. Understand it very well and then try writing these proofs once again without referring this video.